morning, students. In this lecture, I am going to solve problems on finite Fourier cosine transform, students. Let us see the problem. Find, write down, students, the finite Fourier cosine transform of f of x, that is equal to pi by 3 minus x plus x square by 2 pi, comma 0 less than x less than pi, students. 0 less than x less than pi. Now solution given f of x, that is equal to pi by 3 minus x plus x square by 2 pi, students. 2 pi. Now you compare this interval 0 less than x less than c, students. So c is equal to here pi. C is equal to pi. Now we are applying here, students, finite Fourier cosine transform. So the finite Fourier cosine transform of f of x is what is all, students? Fc of n, that is equal to integral 0 to c f of x cos n pi x by c into dx, n pi x by c into dx, students. So that is equal to integral 0 to, what is c, students? Pi. What is the f of x, students? Pi by 3 minus x plus x square by 2 pi, into cos, see, students, c value is pi, students. C value is pi. So pi cancel, students. We get here n x dx, or students, n x dx. Now what is generalization of integration by parts, students? Integral of uv, that is equal to u v1 minus u dash v2 plus u double dash v3 minus and so on. Now say, students, this is u and this is v, students. uv. So pi by 3 minus x plus x square by 2 pi integration of cos nx, students. Sin nx by n minus derivative of this, students. Derivative of this, we get here pi by 3 is 0 minus x is minus 1 plus x square derivative is 2x by 2 pi cancel here. Sin nx integration, students. Sin nx integration. So minus cos nx by n, already we have n here, so n square. Let us, students, plus again derivative, students. Derivative of minus 1 is 0. We get here derivative of x is 1, so 1 by pi. Again integration of minus cos nx by n square, students. We get here minus sin nx by n. Already we have n square here, so n cube. Between the limits 0 to pi. Now substitute upper limit, students. So pi by 3 minus pi plus pi square by 2 pi. Into sin n pi, students. Sin n pi value, students, 0. We know sin n pi value 0 and cos n pi value minus 1 whole power n, students. See, students, here minus 1 plus upper limit, students, pi cancels plus 1, again minus 1 plus 1, so value 0, students. This value also 0. minus cos n pi by n square. This value also 0, students. Minus sin n pi, students. So sin n pi also 0. Sin n pi value also 0. Now substitute lower limit, students. Substitute lower limit. We have sin 0, students. So minus sin 0 value 0, students. Minus. So 0, students. This is 0. See, students. So we have 1, 2, 3. Lower limit is 4. 4 minus, students. So plus. So cos 0 value is 1, students. So we get 1 by n square minus sin 0 value is 0, students. Sin 0 value is 0. Finally, we get here, students, 1 by n square. 1 by n square. This is finite Fourier cosine transform. Here n is not equal to 0, students. N is not equal to 0. If n is equal to 0, students, if n is equal to 0, okay, students, if n is equal to 0, see here, if n is equal to 0, n is equal to cos 0 value is 1, students. Cos 0 value is 1. So fc of n, that is equal to fc of 0. N value is 0 because fc of 0 integral 0 to pi by 3 minus x plus x square by 2 pi, students, into dx. That is equal to, because cos 0 value is 1, students. So simple integration, students. Pi by 3 x minus integral of x is x square by 2 plus 1 by 2 pi into integral of x square, students. So x cube by 3 between limits 0 to pi, students. So that is equal to upper limit, students. So pi into pi cube, pi by 3. So pi square by 3 minus here pi square by 2 plus pi cube by 6 pi, students. Whenever I substitute lower limit, all the values are 0. All the values are 0. So this is 2 times. This is 2 times. So LCM of these two is a 6 here, students. So we get here 2 pi square minus 3 pi square. So we get a minus pi square. So plus pi square by 6. So the value is, students, 0. If n is equal to 0, the integration value is 0, students. Integration value is 0. So the Fourier cosine transform of given function is 1 by n square and n not equal to 0. Let us see another problem, students. Find the finite Fourier sine transform of f of x, that is equal to x 0 less than x less than pi by 2 and pi minus x pi by 2 less than x less than pi. This is discontinued type problem, students. So what is pi, student? What is c, students? Here c is equal to pi, students. C is equal to pi. So what is test, students? Finite Fourier sine transform. So solution: the finite Fourier sine transform. What, students? Sine transform of f of x is of course, students, in the interval 0 less than x less than c. See, so fs of n, that is equal to integral 0 to pi, sorry, students, right here c, 0 to c f of x sine n pi x by c into dx. So that is equal to integral, actually c is equal to pi, students. So you split the limits 0 to pi by 2 and pi by 2 to pi, students. So 0 to pi by 2. Here we have pi by 2, students. So f of x value, students, x sine n pi x by c value, students. C value is pi. So pi cancel, students, into dx plus integral. Now another limit, students, pi by 2 to pi. So pi by 2 to pi. This time f of x value is pi minus x. So pi minus x sine. See students, c value is pi cancel here. We get sine nx. Sine nx dx. Sine nx dx. Now you apply generalization of integration by part, students. Integral uv is equal uv1 minus u dash v2 plus u double dash v3 plus minus and so on. So here that is equal to, this is u and this is v, students. So x into integral of sin nx, students, minus cos nx by n, students, minus u dash, derivative of x is 1. So integral of cos minus cos nx by n. So minus sin nx by n. Already we have n here, n square, between limits 0 to pi by 2. 0 to pi by 2 plus pi by 2. Here also u is pi minus x and v is sin x, students. So pi minus x, integral of sin nx, students. So minus cos nx by n minus derivative of pi is 0, students. Derivative of minus x is minus 1. Again integral of minus cos nx by n, students. So minus sin nx by n square between the limits pi by 2 to pi. That is equal to substitute upper limit, students. So minus x value is pi by 2. So pi by 2. Already we have n, students. So n cos x value is pi by 2, students. So n pi by 2. Minus into minus plus sin n pi by 2 by n square. Whenever I substitute lower limit here by x quotient, so value is 0. Here sin 0, 0. Finally lower limit value is 0. Plus substitute upper limit here, students. Pi minus pi, value 0. Sin n pi value, students. Sin n pi value 0. So this value also 0. Substitute lower limit, students. Lower limit minus pi minus pi by 2, students. We get here pi by 2 minus into minus plus cos n pi by 2 by n, because x value is pi by 2. So n pi by 2 by n. So we are substituting lower limit, students. So minus 1, 2, 3, 4 minus, students. So plus sin n pi by 2 by n square. See, students, minus pi by 2 n cos n pi by 2 plus pi by 2 cos n pi by 2 by n here. Here also n, students. N are cancel, students. Cancel. Now see, students, plus sin n pi by 2 by n square plus sin n pi by 2 by n square. So this 2 by n square sin n pi by 2. This is the Fourier finite, students. Finite Fourier sine transform of given function. These two problems are very, very important, students, for exam point of view. Do it carefully. If you have any doubt regarding these two problems, please comment in the comment box, students. Hope you understand. Thank you for watching this video. Jai Hind.